High nose. Just those two words. They conjure up a pretty intriguing image, don't they?
They certainly do.
Well, that's the name of the dinosaur we're diving deep into today, Altirhinus. This fascinating creature lived in early Cretaceous Mongolia, and our goal in this session is, well, to really understand what made it so unique based on the scientific evidence we have.
And that evidence, it comes from a few key areas. You've got its initial scientific classification, the details of its discovery
Right.
during those joint Soviet and Mongolian expeditions back in 1981, and then there's the ongoing analysis by paleontologists since then. They all contribute.
Absolutely. And all these pieces, they were found in the Kurunduk Formation, right? In Mongolia's Dornogovi province.
That's the spot. Dates back to the Birimian and Albian stages of the early Cretaceous, so roughly 125 to 100.5 million years ago.
And other dinosaurs were found there too.
Yeah, fossils of Psittacosaurus and Chamosaurus turned up in the same rocks. Gives you a bit of context for the ecosystem.
Okay. So our deep dive today is all about piecing together Altirhinus. Its defining characteristics, how it likely lived, and, where it fits in the bigger dinosaur picture.
Sounds good.
All right, let's get started with this high nose. Where did these fossils first come to light?
Okay, so the story really begins with those Soviet Mongolian expeditions in '81. They were really instrumental in finding the very first Altirhinus fossils.
Right.
The main one, the holotype specimen, that's kind of the reference point for the species. It's cataloged as PIN 33868.
And what did that include?
It's actually a pretty significant find. A well-preserved skull, especially the left side, plus parts of its hands, feet, and the shoulder and pelvic girdles.
Wow, that's a fantastic starting point. A good chunk of the skeleton to give us some initial clues.
Definitely.
And I understand that wasn't the only material found.
You're right. They also found another skull, though it was more incomplete.
Okay.
But importantly, it came with associated ribs, some vertebrae, and a complete forelimb. That's really valuable for understanding the arm structure.
Yeah, absolutely.
And then there were remains of a smaller individual, lots of limb bones, and a big part of its tail, something like 34 vertebrae, plus 2 even smaller, quite fragmentary skeletons nearby. We think those are probably juveniles.
So a whole range of individuals. That must give insights into how it grew.
Potentially, yes. It gives us a snapshot across different life stages, which is great.
That sounds like it must have been a really exciting discovery at the time.
Oh, definitely.
But it wasn't always called Altirhinus, was it? There was an earlier name.
That's correct. Yeah, initially the fossils were assigned to Iguanodon orientalis. That species was first described way back in 1952.
Okay.
But then in 1998, the paleontologist David Norman took a closer look.
Ah.
Well, he concluded that the original I. orientalis material, the stuff from '52, was just too fragmentary. You couldn't really distinguish it properly from the well-known European Iguanodon bernicertensis.
Ah.
And since these new Mongolian specimens clearly had unique features you couldn't just attribute to that older, less complete stuff, well, a new name was needed to reflect how distinct they really were.
And that new name, of course, was Altirhinus curzanovi. Let's break that down. High nose seems pretty obvious given the feature. But what about the full name, the origins?
Right, so Altirhinus comes from Latin and Greek. Altus is Latin for high, and hris, or rhinos, is Greek for nose or snout.
So literally high nose.
Exactly. It directly references that big nasal arch. And the species name, Kurzanovi, well, that honors Sergei Kurzanov.
The paleontologist who found them.
Precisely. He was a really key Russian paleontologist on those original 1981 expeditions. So the name highlights the dinosaur's key feature and recognizes the person crucial to its discovery.
That makes perfect sense. It's not just catchy, it's scientifically grounded. Okay, so beyond this high nose, what did Altirhinus actually look like? Give us a sense of its size, its build.
Sure. So the initial estimates, right after it was described, put it at around 8 meters long. That's about 26 feet snout to tail tip.
Pretty big then.
Yeah, decent size. Though Gregory S. Paul in 2010 suggested maybe a bit smaller, closer to 6.5 meters, or 21 feet, and weighing around 1.1 tons.
Okay, still a substantial animal.
Oh, yeah. A solid herbivore. The skull itself was quite long, about 760 millimeters, with a notably wide mouth. But, as we keep saying, that tall arched structure on the snout, that was the defining feature.
That arch definitely sticks in your mind. How did it move around, though? Mostly 2 legs or 4?
The evidence, it leans towards primarily bipedal. Its arms, the forelimbs, were quite a bit shorter than the hind limbs.
How much shorter?
roughly half the length. That's a proportion you often see in dinosaurs that walked mostly on two legs.
Okay.
And this is where it gets really interesting. You look at the hands. The wrist bones, the carpals, they were thick and blocky, very sturdy. And the middle three fingers were broad, and they could bend backwards quite far, hyperextendable. And they ended in these wide, almost hoof-like bones.
Hoof-like. So what did that suggest?
Well, that combination strongly suggests that while it probably walked on two legs most of the time, its forelimbs could definitely bear weight.
Ah, so it could stand or maybe walk on all fours too.
Exactly. It probably adopted a four-legged stance sometimes, maybe especially when it was feeding down low.
So you can picture it striding along on its back legs, but then leaning down, supporting itself on those sturdy front limbs to eat. That's really adaptable.
It seems so, yeah.
You also mentioned some other weird finger features, a spike and maybe an opposable digit.
Right. The first digit, like the thumb, was modified into this stout, sharp spike.
Yeah.
Very similar to the thumb spike you see in Iguanodon.
What was that for? Defense.
That's one possibility, yeah. Defense against predators?
Hmm.
Or maybe for something more mundane, like breaking open tough plants or pulling down branches.
And the fifth finger?
The fifth digit, the pinky, showed some signs of being slightly opposable. It could likely move a bit independently.
Helping it grab things.
Probably helped it grasp or manipulate food items, bringing them closer to its mouth.
Its hands sound like little multi-tools.
Kind of, yeah.
Okay, let's talk more about eating. You mentioned the wide mouth and a gap between the beak and teeth. What's the point of that setup?
That gap, it's called a diastema, and it's a really key adaptation for herbivores.
How so?
It essentially separates the front of the mouth, which would have had a beak, probably keratinous, for cropping vegetation from the main chewing teeth further back.
So like two separate processing stations.
Exactly. It could snip off leaves or twigs with the beak, while the back teeth were already busy grinding up the previous mouthful.
That sounds very efficient for dealing with tough plants.
It is, and it's a strategy we see evolve independently in lots of herbivorous mammals, too. You know, think of a cow or a horse, similar idea.
So this high-nosed dinosaur had a pretty sophisticated way of processing its food.
It seems quite advanced for its time, yes.
And you also mentioned the snout widened out towards the front. That makes me think of the duck-billed dinosaurs.
Yeah, that's a really interesting point, that outward flaring of the snout in Altirhinus. It's quite possibly an example of convergent evolution with the later hadrosaurids, the duckbills.
Convergent evolution, meaning they evolved the same feature independently.
Right, because they were likely adapting to similar conditions or lifestyles. A wide muzzle is also common in modern grazing mammals. Think cattle, horses again.
Okay.
So since grazing means eating low to the ground, this wide snout in Altirhinus combined with those weight-bearing forelimbs we talked about.
It suggests it was probably grazing.
It strongly suggests it spent a good amount of time eating low-lying plants, yeah.
That paints a much clearer picture. Okay, back to the main event, that nasal arch, the high nose. You said there were a few different ideas about its function. It wasn't just there.
No, it's highly unlikely it was just random, especially given how prominent it is. This arch, mostly made of the nasal bones, is seen in some others too, like the Australian Muttaburrasaurus.
Right. So what are the theories?
Well, there are several. One idea is it housed tissues for cooling blood useful in a warm climate.
Like a radiator.
Sort of, yeah. Another is water conservation, maybe condensing moisture from exhaled air, or perhaps it enhanced its sense of smell.
Locating food or danger.
Could be. Then there's communication. Maybe it acted as a resonating chamber for making sounds, amplifying calls.
Like some modern animals use nasal structures.
Exactly. And finally, visual display. Maybe it was bigger or more colorful in one sex, used for attracting mates or showing dominance like, say, elephant seals today.
Wow, that's a lot of possibilities. Cooling, water saving, smell, sound, looks.
Right. And given we don't have tons of perfectly preserved skulls, it's hard to pin down the main function. It might even have served multiple purposes.
It really makes you think about the environment it lived in, what challenges it faced.
It does. The fact that one feature could potentially be linked to so many vital functions is fascinating.
Okay, let's shift gears slightly. Where does Altirhinus fit in the grand scheme, its place in the dinosaur family tree?
Right, taxonomy. As we touched on, it's considered an advanced iguanodontian.
Meaning?
Meaning in evolutionary terms, it's relatively close to the base of the Hadrosauridae family, the duckbills.
Closer than Iguanodon itself.
Yes. So when Norman first described it in '98, he grouped it in the Iguanodontidae family with Iguanodon and also Tyrannosaurus.
Okay.
But more recent studies, phylogenetic analyses that reconstruct evolutionary relationships, they consistently place Altirhinus as more derived, more evolutionarily advanced than those two.
So further along the branch towards duckbill.
Exactly. It shares a more recent common ancestor with the hadrosaurids.
Hmm.
Studies by Head in 2001, Kobayashi and Azuma in 2003, Norman again in 2004. They all generally agree Altirhinus sits somewhere between those earlier iguanodontians and groups like Protohadros, Probactrosaurus, and then the true hadrosaurids.
So it sounds like Altirhinus is a really interesting transitional form, kind of an evolutionary stepping stone.
That's a good way to put it, yeah. It seems to represent that phase of evolution leading towards the great radiation of the duckbills.
Are there any ongoing debates about its exact placement? Does everyone agree on the fine details?
Oh, definitely still some debate. While the general position relative to Iguanodon, Tyrannosaurus, and the hadrosaurs is pretty well established,
Oh,
the exact relationships with other early hadrosaurids are still being figured out. For instance, where Eolambia fits in relation to Altirhinus.
another contemporary dinosaur.
Another early herbivore, yes.
Right.
Some studies put Eolambia between Altirhinus and the hadrosaurids, like the next step. But Norman's 2004 analysis suggested maybe Altirhinus and Eolambia formed their own little group, a sister clade.
Interesting.
And that 2003 study by Kobayashi and Azuma, they included the Japanese dinosaur Fukusaurus. Their results suggested Fukusaurus might be even more basal branching off earlier than Altirhinus.
So the family tree is still a bit fuzzy in places.
Precisely. We have a good overall picture, but the finer branching pattern, exactly who is most closely related to whom among these early forms, that's still being refined as we find more fossils and improve our analytical methods. It's a constantly evolving picture.
It really highlights how science works, constantly refining ideas with new data. Okay, let's circle back to Altirhinus's lifestyle and just recap some key adaptations. We talked about moving on 2 legs and 4. How did that likely play out day to day?
Yeah, to summarize, the longer, stronger hind limbs point to bipedal walking or running as its main way of getting around, maybe for speed, maybe for a better view.
Right.
But those sturdy forelimbs with the weight-bearing fingers mean it could definitely switch to a quadrupedal posture.
Probably for feeding.
Most likely, yeah. Especially for grazing low to the ground for longer periods like many modern herbivores, it gave it flexibility.
And that feeding system, beak for snipping, teeth for grinding, separated by that gap.
The diastema, yeah.
Yep.
That setup allowed for really continuous and thorough processing of plants, maximize nutrient extraction.
Essential for a large herbivore.
Absolutely. And combined with that broadened snout, it really paints a strong picture of a grazing lifestyle, showing that fascinating parallel evolution with other grazers, past and present.
It really makes you wonder about the specifics of its environment in early Cretaceous Mongolia.
What pressures favored those traits?
So to wrap up our deep dive on Altirhinus,
Yeah.
we've got this dinosaur from early Cretaceous Mongolia named for its very distinctive high nose,
That prominent nasal arch, yeah.
whose function is still debated, could be cooling, communication, display, maybe several things.
A biological multi-tool, perhaps?
It was a sizable herbivore, probably moving on both 2 legs and 4, with specialized hands and that efficient 2-stage feeding system.
Right.
And evolutionarily, it holds this important spot as an advanced iguanodontian, giving us clues about the path towards the duckbill dinosaurs. What a remarkable creature.
It really is. Altirhinus is a fantastic example of how evolution shapes unique adaptations in response to environmental pressures. It gives us a valuable window into those early Cretaceous ecosystems.
So, as we finish up thinking about the high-nosed Altirhinus, here's a final thought for you, the listener, to ponder.
Oh.
Considering all those potential functions for the nasal arch regulating temperature, communicating, maybe attracting mates, what specific conditions in early Cretaceous Mongolia might have favored evolving such a potentially versatile feature? Were there unique challenges or opportunities in its world that really pushed the development of this distinctive high nose? It really gets you thinking about the interplay between an organism and its environment, doesn't it?
It certainly does.
If you want to explore more, maybe delve into the paleontology of the early Cretaceous or look up other discoveries from that Curan-Duke formation, there's always more to uncover in the amazing story of life.